In our previous lesson, we were looking at individual and summary data sets, how we can make dot plots for individual data sets. We can make summary data set plots for box plots and histograms. And we talked about making some valid conclusions based on what those items tell us. So here we're going to do a couple reviews and then get into more constructions and evaluations from there. So it says Sam said that 50% of the 22 juniors at River City High School who participated in the walkathon walked at least 10 miles. Do you agree? Why or why not? So if we look, we're given a box plot of miles walked for juniors, and we can see our scale by twos for the miles that are walked. So we want to think about, is Sam's statement valid, and how can we justify that? Well, it says 50% of the 22 juniors walked at least 10 miles. So as I'm looking here, here's our 10-mile mark, right? And we want to have at least 50% walked past that. So if I'm thinking about drawing a line here, let's think about how that compares to our box plot. As we talked about previously, our box plot is broken up in two quarters. The minimum to the lower quartile, often referred to as quartile 1, is 25% of our data. Quartile 1 to the median is 25% of the data. The median to our upper quartile, or quartile 3, is 25% of the data, and from quartile 3 to our maximum is 25% of the data. So if I'm looking at where that cutoff for 10 is, 1, 2, 3 quartiles are below that. So more than 75% of the data is less than 10 miles. So Sam's statement saying that 50% of the juniors walked at least 10 miles can't be correct. So we're going to have to say it's false because 75%, 1, 2, 3 quartiles is below the 10-mile mark. Let's look at another data representation. For this one, Sam said that young people from the ages of 0 to 10 years old make up nearly 1/3 of the Kenyan population. And we want to know if we agree with Sam's statement or not. So here we've got a histogram. We have to remember that histograms are summaries of data again. And so we're going to have to see if the statement is valid. So it says from the ages of 0 to 10 years old. So here's our ages, and we can see that the bins, the class widths, are 5 years of age. And we have the percentages of the population that fits in those items. For example, from here to here, that's ages 0 up to but not including 5. So we're going from 0 to 10, that's this first bin and the second bin. So we're focusing here, okay? So if I look at their frequencies from 0 up to 5, that's about 17%. 5 up to 10, a little bit more than 14, so you could call that 15 as we're estimating. We want to know if it's nearly 1/3 of the population. Well, 1/3 is 33%. So let's think about that. If we talked about the 17% and the 15% from those two bins here, that's about 32%. And again, we're estimating, right, those frequencies based on what we see. Well, he said nearly, 32% is nearly 1/3 of the 33.3% for our population. So that could be a valid statement to make. Nearly 1/3 of the population is young people from ages 0 up to 10 years old. All right, let's transition into, again, creating some representations for the data and seeing what conclusions we can draw. So here we have 25 car owners asked the age of their cars in years, and they recorded them below. The first thing they want us to do is to make a box plot for the data set. And again, box plots are summaries of the data set. So I'm going to ask you to pause the video here and then resume to check your construction of the box plot. When we're making a box plot of our data set, we have to calculate the 5-number summary. And our 5-number summary is made up of the minimum, our first quartile, the median, our third quartile, and the maximum, right? So we can go through and quickly identify our minimum being 0, our maximum being 8. We're going to work our way in from the two ends to find our middle value. If there isn't one number that's in the middle, we're going to take the average of the two numbers in the middle, and that would be our middle value. But since there's 25 car owners, right, that means there would be 12 numbers on each side to get to our middle number. And so our middle number is 7. So that would be our median. So if this is our boundary here, we're then going to have to calculate the median of our lower half of our data, and that would be our lower quartile or quartile 1. And we're going to have to find the median of our upper half of our data. That would be our upper quartile or quartile 3. And calculating our lower quartile, that would be between the 4 and the 5 mark, so that would be 4.5. And our upper quartile is between these two 8s, so it would be 8. So if I fill in my 5-number summary, this is what I have: 0, 4.5, 7, 8, and 8. When we go to construct our box plot, we typically start with the 50% of our data in the middle, from the lower quartile to the upper quartile. So with the median, I would put a segment at 7, a segment at 4.5 for the lower, and a segment at 8 for the upper. And that I would draw my box to represent that piece of our data. So it looks something like this. Then I would put some points to represent our minimum and our maximum. Well, our minimum is here at 0, and our maximum here is at 8. Notice that 8 is also your upper quartile, so we're really not going to see that point for the maximum because it's included in the upper quartile. What I want to check is if there's any outliers with our data set, because typically I would connect these, right, to show the minimum to the first quartile. So it looks something like this. But I want to see if that's going to be an outlier or not. So remember, we have to find the interquartile range. So that's the upper quartile minus the lower quartile, Q3 minus Q1. And we're going to measure 1.5 times its distance from the lower quartile for the left to see if there's any outliers, and also from the upper quartile to the right. So my interquartile range ended up being 3.5. So again, from our lower quartile, we're going to go 1.5 times that to see what the value is. And then we're going to go 1.5 times that to the right of the upper quartile and see what that value is. Now I end up with a negative 0.75, and we know age can't be a negative, so that says we don't have any lower quartiles, so this is fine here. And then our outlier boundary for to the right would be 13.25 years. I don't have any data points to that to the right, so I don't have any outliers to the right. So this is our data set, no outliers involved. From here, we're going to look at some evaluation and inferential questions, right, based on the data. So the first one says, is the box plot of the age of the car symmetric or skewed? So we don't have any outliers, so we can look at that as maybe saying it could not be skewed. But we also want to look at a couple other things. We calculated the median of the data, but we also want to know the median and the, we have the median. We need to know the mean and the mode to help secure what we think it is. Right now, it appears that it's skewed to the left, right? Because most of the data is clustered here on the right, so it's trailing off to the left. So what we're going to do is say, okay, well, if we think it's skewed to the left, we're going to do the calculations to see if the rule is true. Is the mode greater than the median and the mean? That would cement that in. Well, if I wanted to calculate the mean of my data set, I would have to go back up here, add the 25 ages of the cars, and divide by 25 to see what we get. So if I do that calculation, let's see, I add up all the values, I think that's going to be about 146. And if I divide that by 25, my mean is about 5.8 years. And we can have parts of years that's valid for the age of the car. The median, we already calculated that to be 7 years. Now, if I'm looking at the mode of my car, the one that happened the most, I can go back up to my data set and I can see that's happening with 8, right? The mode is 8. So the mode is greater than our median, which is also greater than our mean. So it's cementing the fact that it is skewed to the left. And since it is skewed to the left, when I talk about picking a measure of center between like the mean or the median, what would be best, I don't want to pick the mean because that value here of 0s, 1s, and 2s is pulling down the value for the mean, right? So the best pick would be the median because it's countering that skewed data. It really is a better measure of the center of the years of age for the cars. All right, we're going to take a look at another set of data talking about the ages of U.S. presidents. So this is for the ages of the presidents that took office through the 2020 election, and they are here in chronological, not in chronological order, I'm sorry, in numerical order, right? So that helps us because everything is from their smallest to the largest. What we would like to do is create a histogram for our data set. And then we also want to look at a couple of other items. We want to calculate the mean, the median, and the mode, because that will help us figure out if the data set is symmetric or skewed. We also want to pick which of the 3 would be a better description for the typical age of all the US presidents when they took office through the 2020 election. So let's have you pause the video and have you work on constructing the histogram. Also calculate the mean, median, and mode to help make our decisions about 5 and 6. Resume the video when you're ready for a check. All right, I'm going to go a little bit backwards. Let's take a look at some of the calculations first, and then we'll go over the histogram. So when we talk about the mean age for all the US presidents, we're going to take the sum of all of their ages and divide by how many presidents we had, and that was 46. And our mean age is 55.478 years old. Now I want to find the median age for all the US presidents. So the median is I'm starting with one finger on the 42, one on the 78, one on the max, one on the min. And we're going to work our way to find the middle value. Okay, so when I'm doing that, since there's 46 presidents, I'm going to have 2 middle numbers where I'd have to take the average. And so where would that end up? That's between this 55 here and this 55 here. Well, the average of 55 and 55 would be 55. So here's our median data set. So the median age for the US presidents is 55 years old. The mode, the one that happens the most, well, if you look and we see, we have 2 modes. 51 and 54 years of age happen the most for the president's ages through the 2020 elections. Now, if I'm looking at these 3, right, our highest value is the mean, followed by the median, and then our mode is below, both the modes are below those 2 values. So if I'm helping figure out the symmetric or skewed, I could use these to assist me, but I also probably want to look at the histogram for the data set. So remember, not all data sets depictions will tell us that. We also want to compare it with these 3 values as well. Well, when we're making the histogram, the first thing we have to talk is about the class width, right? How big are the bins going to be? We do that by doing the range divided by the square root of the number of data. So the maximum minus the minimum divided by how many pieces we had. And then we're going to take a look and say, well, should I take that value and round it down or round it up? since it's 5.3, we're going to round down and say, okay, my class widths are going to be counting by fives. Now, if we're talking about the ages, notice how our age isn't at 0. And even if I start at 0, there's not a lot of data between 0 and this first age at 42. So I'm going to change it a little bit. I don't need to have blank sections of my graph. What would be a good number to start with when I'm counting the ages? Well, you could start with 42, but if I go with 40, it might be a little bit easier to count my data representation, right, and go from there. So that's what I did. I said my lower bound's going to be 40. I'm going to count by fives. And then I can do the frequencies for each of the bins. So let's show you what I did. If you changed it, have a different starting value, that's fine. You have your evidence where the difference of 5 is present for your lower bounds. We also can see the difference of 5s in your upper bounds. And we just counted how many of the ages fall within that category. So this is what I have. Yours might be slightly different. So based on this, we say we're skipping some ages. So when I go to do my inputs for my graph, we started with those values. So here's your lower bounds, 40, that would be a 45, 50, 55, 60, and so on. I just want every other one so we could see. Our frequencies, you can count by whatever you like. I counted by ones, just marked every fifth one. So these are going to be the heights of our bins for the class widths. Let me take this off here. So our first one, this is from 40 up to 45, not including it. There's our frequency of 2. Here's our next one, 45 up to 50. Here's our frequency of 7, and so on and so forth. So we can see the frequencies based in each bin for the class width on our histogram. So again, we look at the shape, right? We see a lot of clustering here, but we have a couple over here. So if we're talking about the shape of the data, we wouldn't necessarily say that it's symmetric. It's not like a nice bell-shaped curve. We do have a little bit of grouping here on the left, and it's drifting off to the right, so skewed would be better. Also, your definition of skewed is saying that your mean is greater than your median and greater than your mode, so that's supporting our evidence. So we do want to say that it would be skewed to the right. We probably have an outlier. We could calculate that again with your 5-number summary if we wanted to. We also can see a little bit, right, how we have some much higher numbers with our ages versus the rest of the data set. So for a probable outlier, so if we have a possible outlier, what would be the best measure of center? That would be our median, right? Because we want to go something that's going to offset the skewedness of the data. The middle value is going to be better of a measure of all the US presidents up through the 2020 election as our data representation. Again, here, if you were calculating the outliers, anything above 73.5 or below 37.5 would solidify that case. So now you're going to do some more data analysis with your day 2 practice, looking at some data sets and trying to make box plots, histograms, and dot plots, finding your measures of center, mean, median, and mode, seeing if the shape of the data is symmetric and skewed, if it's skewed, which direction it's going to go, and do some more practice so we can do more analysis going forward.